everybody. And in this session, we will begin by revising what we have done in the previous session to understand the concept of equal ratios, the concept of equivalent fractions. We will use this concept of equivalent fractions to convert any addition problem where we are adding problems into a problem of adding pieces of the same size, which, as we know, are very easy to do. So now let us begin by revising a little bit about ratios, equal ratios, and equivalent fractions. So are we ready now to go to the next problem? Again, we will do a bit of revision. Remember, we discussed about ratios in the last session. And we saw that ratios can be equal. We saw that if I divide 4 by 2, what answer do I get? 2. And if I divide 6 by 3, what answer do I get? 2. So since 2 is the answer for this division as well as for this division, I can put them equal. And this something upon something, this division problem is called a ratio. So these two ratios give the same answer, which is 2 by 1. And they are all equal. Remember, we have done this exercise in a previous session?
Yes.
Okay. Now I am going to give you some problems just to revise what we have done in the previous session and get ready for the next part of addition. I am going to write a ratio but I'm going to leave one part blank. Okay. So Nandita, what will I have to get here?
5.
5. Okay. Now, supposing instead of that, I wrote 8 here. So Gyanjyoti, what should I have up here?
4.
4. Right? So when I have 4 here, I get the same ratio. It's like this. In division, 2 divided by 1 is the same as 8 divided by 4. So in fractions, 1 upon 2 is the same as 4 by 8. We have done this problem last time. So now, I want you to take your slates and write some ratios which are equal to 1 by 2. Okay, show us what you have written. 1 by 2, 3 by 6, 2 by 4, 4 by 8, 6 by 12, 7 by 14. On the other side of the slate, write some ratios which are equal to 1 by 3. No, leave what you have written on one side, keep that there. On the other side of the slate, write some ratios which are equal to 1 by 3. 1 by 3 is equal to 2 by
6.
Write some more, Gyanjyoti. Five by right, that's enough. So all those ratios are equal to 1 by 3. Now look at both sides. Can you find a ratio for 1 by 2 which is made with the same size of pieces as a ratio for 1 by 3? Now, for example, take the ratios for 1 by 2. Okay, look at those ratios. Which is the ratio which is made of pieces of 1 by 4, which is equal to 1 by 2? Okay, let's again discuss that. This is what you have written, Gyanjyoti. So here the pieces are
6.
Show me the pieces for this. You have made them. Show me one piece. Okay, so show me this 3 by 6. So this ratio is made up of pieces of
6.
1 by 6. Okay. 6 is a big thing. 1, 1, 1. Those pieces are 1 by 6. So here the pieces are 1 by 6. Now, you also have written this. Here the pieces are
4 by 8.
no, each piece is
1 by 8.
1 by 8. Here the pieces are 1 by 8. Here the pieces are 1 by 6. So look at what you have written and tell me which are the pieces for each. For 1 by 2 you have written 5 ratios, Gyanjyoti. So the first one, just show that in the camera. Take your slate which you have written, show that in the camera. Now the first one, 3 by 6, the pieces are
1 by 6.
1 by 6. Look at the second one,
1 by
pieces are 1 by 4. Look at the third one,
1 by 8.
1 by 8. The fourth one, pieces are
1 by 10.
1 by 10. And the last one,
1 by 12.
1 by 12. Okay, now look at the pieces that you have made for the ratio 1 by 3, Nandita, and tell us what are the pieces for each of the ratios. Show that in the camera. Okay. 2 by 6.
1 by 6.
Pieces are 1 by 6. 3 by 9.
1 by 9.
Pieces are 1 by 9. 4 by 12.
1 by 12.
1 by 12. 5 by 15.
1 by 15.
1 by 15. So if you look at both sides, then where are the pieces equal? Say in 1 by 3, you have pieces of different sizes. For 1 by 2 also you have taken different. But can you make 1 by 3 and 1 by 2 with pieces of the same size? What are those pieces?
3 by 6 and 2 by 6.
Yeah, so the pieces are
1 by 6.
1 by 6. So if I take pieces of 1 by 6, I can make 1 by 2 as well as I can make 1 by 3. So take a plate, each of you, and make make 1 by 2 and 1 by 3 with pieces of 1 by 6. Make this first 1 by 2, pieces of 1 by 6. That's 1 by 2 with pieces of 1 by 6. Make this with pieces of 1 by 6, 1 by 3. Keep it in the plate. 1 by 3, make it with pieces of 1 by 6. Look at what you have written. No, for 1 by 3. Okay. So which is 1 by 2, Yanjoti, in your plate? Keep that separately. And which is 1 by 3? That. When you add them, you put them together. And what do you get?
5 by 6.
5 by 6. So 1 by 2 plus 1 by 3 is equal to
5 by 6.
5 by 6. Here I did not add 1 plus 1. Okay. What I did is that I converted this into a ratio which is made up of pieces of the same size. Alright. Alright. Now, let me give you another problem. Take the problem take 1 by 2 in your plate. One by 2. I have not asked for pieces. Take 1 by 2. So that is 1 by 2 plus 1 by 4. Now can you cut the pieces so that in your plate you have all the pieces of the same size? All that you've done is you've cut 1 by 2 into 2 pieces. And now you have all the pieces of the same size. Which piece do you have now? Each piece is Gyanjyoti? Each piece is
1 by 4.
1 by 4. And how many pieces do you have?
3 by 4.
You have 3 of them. So your answer is
3 by 4.
3 by 4. Okay. Alright. So what we have to do while adding fractions where the pieces are not of the same size, what we have to do is to convert it into a problem where the pieces are of the same size. Right? So, keeping that in mind, are we ready to do one more problem? This is the problem. 1 upon 2 plus 3 upon 8. So here the pieces are
1 upon 8.
1 upon 8. Here the pieces are
1 upon 2.
1 upon 2. So which one will I have to cut?
1 upon 2.
1 upon 2. Right? So I will cut this and make this in pieces of
1 upon 8.
1 upon 8. How many pieces of 1 upon 8 are there in 1 upon 2? Take 1 upon 2 and make pieces of 1 upon 8. Okay, so Gyanjyoti, make this with pieces of 1 by 8. Good. And make this with pieces of 1 by 8. You keep that there. And make this now with pieces of 1 by 8. So Gyanjyoti, make this piece now. And now when I add them, I put them all together. And what is the answer? What is the short form of that?
7 by 8.
7 by 8. So 1 upon 2 plus 3 by 8 is equal to
7 by
7 upon 7 by 8. Okay. Shall we do 1 or 2 more problems just to confirm what we have learned? We saw that we can write ratios for 1 by 3. Okay, so now take your slate and write ratios for 2 by 3. These are the ratios for 1 by 3. Now, what will be the number here?
4.
Okay. So 2 by 3 is now 4 by 6. And if I take this as 9, then what do I get here?
6.
6. Very good. Okay. So we know how to write equal ratios. These equal ratios are called equivalent fractions. So now we have learned how to do additions of fractions even when the pieces are not of the same size. So 1 by 2 plus 1 by 3. Here the pieces are 1 by 2, here the pieces are 1 by 3. If I convert this using equivalent fractions into pieces of 1 by 6, then this becomes 3 by 6, and 1 by 3 becomes 2 by 6. And now the pieces are of the same size, so I can add them very easily. 3 cats plus 2 cats,
5 by 6.
5 cats. So the answer is 5 by 6. So I get 1 upon 2 plus 1 upon 3 is equal to 5 by 6. So we start out with the problem, we convert into equivalent fractions so that the pieces are all of the same size. Because the pieces are of the same size, we add them like 3 cats and 2 cats. So we get the answer in pieces, we count the number of pieces. That is the long form, and we write the answer in the short form. That is the whole process of addition of fractions. And you can practice by going to the website ebcdmath.org. There are some more problems, some worksheets, some assessments. If you have understood what we have done today, with a little bit of practice, you will find that addition of fractions is something that is very easy. It is as easy as 3 plus 2. So we will conclude this session here, and in the next session, we will take up the subject of subtraction of fractions. 3 minus 2. Thank you.